Today I'm going to tell you how does current flow. Okay. Now the current will always flow from positive to the negative. Okay. Uh, it looks like this. If I have a circuit, well, with a resistance, it will flow from positive to negative. However, what we found out is if I connect an extra wire providing a bypass to the resistance, it looks like this. Now, the current will flow bypass the resistance. Okay. Okay. This is because the resistance is the ability to uh, resist the current. Okay. On the top, okay, on the top wire above the resistance, okay, the the resistance is zero. Okay, so current is most likely to go through a path with less resistance. Okay, so this is why we found uh, more current through there. Okay, by the way, the resistance on the top is zero. Okay, so all the current will flow through the top. Okay, well here, let's look at this picture here. Here is the circuit board of a ancient mobile phone. Okay, now you say it's really complicated. Okay, if you look at a modern one, okay, the circuit board of a modern, let me find something like this. Okay, of a modern mobile phone is more complicated. Okay, so each line means each colored line has a what I call it has a it's a conductor. So electricity actually current goes through each of these lines and goes through the resistance. Uh, if I provide you something more complex like this, okay, just give it a second. It's loading. Um, okay, so now, okay, sorry, okay, now have a look what's happened if you drop your phone. Okay, so in the circuit, okay, of a mobile phone here. Okay, now each of those lines, each of the resistance sometimes means a device. Okay, if the current doesn't go through the resistance, means that the device doesn't work. Okay, so what's happened is if I drop my phone, okay, so if I drop my phone in water, now say if I have something like this, I have a resistance. Okay, so if I drop my phone in water and somehow the waters actually let me use this. Doesn't work. So uh, somehow okay, the water get a connection bypass the resistance. Okay, say if this is a water. Okay, then what's happen is when you turn on the mobile phone, okay, the current will go through there. Okay, as a result, the current because water has a less resistance. The resistance is not zero, but it's less. Okay, so a lot of current go bypass the device, so your device doesn't work. So this is why don't drop your phone in water. Okay. Now, have a look at this. Okay, I have two resistors. Okay, so when current travels from the positive to this junction point here, the current splits up. Okay, it splits up to I1 and I2. Okay, I1 went across resistor 1 and I2 went across resistor 2. Okay, since the resistance are the same, so what's happening is the current is going to split in half. Okay, so they're going to be 6 amps each, and and afterwards they will rejoin. And okay, now okay, so what's happened is the current splits up, okay, due to the value of resistance. Okay, now have a look at this new example. Okay, say um, we still have two resistance, and I change the value of the top resistance to 200 ohms. Okay. So in this case, we know the current goes a ratio. Okay. So and more current will travel through less resistance. Okay. So I2 should be bigger than I1. Okay. So I2, okay, should be double than I1. So if we do a ratio, okay, so I have three. Well, let's do a fraction. Okay, well, let's to make it easy, let's do a fraction. Okay, so we have two resistance. Okay, they're going to be 300 in together altogether. Okay, now so let's do a fraction. Okay, so if you do two third of the current will go through I2 because the resistance is low. Okay, so if I do that ratio, it will be 8 amps. Okay, so similarly in I1, okay, it will be 1/3, okay, which is 4 amps. So if you have a look, I should have 4 amps on the top and 8 amps on the bottom. Okay, altogether this should be 12 amps. Okay, now, so yeah, okay. Now look at this new example. Okay, in this example, the current 12 amps is going to split into three parts. Okay, so I1, I2, and I3. So as a result, what I do is, okay, um, let's find, well, yeah, let's find a ratio first. Okay, so I have 100 ohm, 200 ohm, and 300 ohms. Okay, and they have a total of 600 ohms. Okay. Now I know it's going to be split into three different current. Okay. So one current would have about 1/6 of the total. The next one would have 2/6 of the total. The second one will be 3/6, which is a half. Okay, so yep. Then do the calculation. 1/6 of 12 will be 2 amps. Okay, 2/6, well, 1/3 will be 4 amps and 6 amps. So what happens? The current is going to be split into 2 amps, 4 amps, and 6 amps. Okay, now I know the 100 ohm resistor has low resistance, so most of the current would go through it. Okay, go through the low resistors, so I can predict the 6 amps are I1. Okay, to make it clear, let me show you. Okay, now to make it clear, I know, okay, because more current will split into into a resistance into a resistor with low resistance. So I know the 100 ohm resistor would have more current. Okay, it will have higher current. Okay. So similarly, okay, okay, the 200 ohm resistor would have a medium current. Okay, and the 300 ohm resistor will have a low current because current doesn't want to go through there. Okay, the resistance is higher. Okay, so I know. Okay, after yeah, from this, after we did the calculation, I know 12 amps are going to split into 2 amps, 4 amps, and 6 amps. Okay, so just put it in. Okay, so for high current, it, it must be 6 amps here. Okay, medium current, it has to be 4 amps. Okay, the low current, it has to be 2 amps. Okay, so let's hold it down.